Hello everyone, my name is Farrell Liam and my student number is 210553108 and today I'm going to present about machining process chapter D to chapter F. So my main reference from this presentation is from the Handbook of Manufacturing Processes, how products, components and materials are made. There's three chapters that I'm going to explain. There's one milling, screw threads and broaching. Go to the first one, milling. Face milling. Face milling operation produces a flat surface at a right angle to the axis of rotation of the cutter. For flat surfaces, face milling is generally preferable to peripheral milling from the standpoints of tool economy, simplicity of setup, and color rigidity. This is the illustration of the face milling operation. This is where the face milling operation works. This is the workpiece and this is the machine. And that's how the process works. Okay, we get into the next one, peripheral milling operation. The milled surface, if flat, is parallel to the axis of rotation of the cutter and is produced by cutting teeth located on the periphery of the cutter body. The operation is usually performed on horizontal spindle machines. The milling cutter or cutters are mounted on an arbor that has outboard support. End milling operation. End milling operation uses a cutter, commonly of smaller diameter, with teeth on both the end and periphery. The approach is versatile in that slots, recesses, and profiles can be machined. Material removal rates are less than with other milling methods and accuracy may not be as great. This is the illustration of end milling operation. This is the tool of the end milling operation. And this is how the process works. This is the workpiece. Okay, so this is how the end milling operation works. We'll get into the next one, slab milling. Slab milling operation is peripheral milling with cutters that produce a flat surface over a wide area. The axis of rotation of the cutter is parallel to the machined surface. The cutter often removes large amounts of material. Two or more cutters are used per arbor with opposing helices to balance cutting force. This is the slab milling and this is the workpiece. This is the video how slab milling operation works. Okay, so that's how slab milling works. For milling. For milling. When the peripheral cutting edges of the milling cutter are ground with a form rather than in a straight line, that form is transferred to the workpiece as the milling operation proceeds. Milling of gear teeth is a common application of this approach. There are some form milling operation: double angle cutter, convex cutter, concave cutter, and corner rounding cutter. And I'm going to show you the video. And this is the cutter. This is the result of this operation. Okay, gang milling. Gang milling operation is simply milling with more than one cutter on the arbor of the milling machine. This operation produces multiple surfaces on the workpiece with one pass of the cutters. As you can see, this is the illustration of this gang milling operation. This is the workpiece and this is the machine. Straddle milling. Straddle milling operation involves the use of two cutters on one arbor with a space between them. Two surfaces are cut in one pass, but the area between them is not machined. So the area machined is right here and right here. The area between this and this is not machined. This is the video. And that is the workpiece. Okay, see, this is how the process works. The area between the two cutters is not machined. The area that machined is the side area. Fly cutter milling. fly cutter milling operation involves the use of a single point cutter rather than a multiple tooth cutter to perform a milling operation. It is face milling with only one cutting tooth. The method is useful for producing flat surfaces in a two-room situation where the optimal multiple tooth cutter may not be available. This is the illustration of the fly cutter milling. Pin route. Pin routing involves the use of a template to guide the movement of a high-speed routing cutter. Typically, the process is used to blank flat stock of sheet metals and or other materials. Stacks of thin material can be cut by this method to produce multiple parts. The next one is spot facing. Spot facing is a simple operation that is normally used to provide a small flat bearing surface perpendicular to the axis of the hole for a bolt head or nut. It is most commonly performed on castings and forgings, where the surface prior to the operation has some irregularity. We get on to the next chapter, screw threads, hand die external threading. These are called button or acorn dies and are useful for cutting screw threads in prototype and limited quantity production. The die is placed on the end of the screw blank and is rotated with a wrench-like tool. As you can see, this is the acorn dies, and this is the thread screw blank. Next, internal thread tapping. This operation utilizes taps. The tap is rotated like a drill or a reamer and is self-fed axially into the hole in the workpiece to create an internal thread. Taps can be positioned and fed manually and rotated with a hand tool, or can be used with a drill press, lathe, automatic screw machine with a tapping attachment, or a special tapping machine. And this is a solid tap for machining internal screw threads. This is the solid tap. And this is the result. The next one is single point screw thread cutting. This is a lathe operation, a form cutting tool that has a profile corresponding to that of the space or spaces between the required screw threads, makes repeated passes along the workpiece. The cutter is attached to the lathe carriage and is moved longitudinally along the bed by the lathe lead screw, which is geared to provide the rotational weight needed to produce a screw of the proper pitch. This method is used for large screws. This is the external thread cutting and this is the internal thread cutting. I'm going to show you a video of external thread cutting. Okay, the next one is thread cutting die heads. These operations are efficient, accurate, and widely used in production threading. They are used on all kinds of lathe and screw machines, on drill presses, and as part of special threading machines. The largest single application is pipe threading, on special small machines that can be transported to building construction sites. This is a die head for external threads with inserted multi-tooth cutter. Thread milling. Thread milling operation utilize a form milling cutter. Both the workpiece and cutter rotate. Most cutters are the multiple rib type, but single rib cutters are also used. Though cutting one thread at a time requires more time. Thread milling operation method is applicable to both internal and external threads. This is the tool in this operation. Now this is the process. As you can see, this is the tool and it's making a thread inside. Okay, so that's how the operation goes. The next one is thread grinding. Thread grinding operation is used when particular accuracy and surface smoothness are required, when heat-treated workpieces are threaded, or when the material is otherwise difficult to machine. With center-type grinding, several passes are usually required. Center-type grinding can be used on short runs, but is not limited to small quantity production. With centerless grinding, the wheel is always dressed for multiple rib grinding. This is the workpiece and this is the single rib wheel. And this is the illusion of thread grinding operation. As you can see, this is the wheel and this is the workpiece. The next one is thread rolling operation. Thread rolling operation is a cold forming method for making external screw threads. The blank workpiece is rolled between opposing dies which have a negative screw thread profile. The dies may be flat or cylindrical. This operation is rapid and is particularly suited to mass production of threaded fasteners. This is the blank workpiece, and the person gives the lubricant. And that's done. The result of this thread rolling operation. The next one is called form tapping of internal threads. Differs from tapping with cutting tabs in that the workpiece metal flows rather than being cut and removed to form the threads. Cold forming tabs produce strong screw threads, but the threads formed fill only 65% or less of the space of full threads. Soft and ductile materials must be used. We go into the last chapter, broaching. Internal broaching operation. This is machining by broaching the inside surface of a hole or other opening in the workpiece. The most common broaching operation produce keyways, key slot openings in locks, spline-shaped openings, and other non-round enlargements of holes in pulleys, gears, or other parts that are to be fastened to shafts. This is the illustration of internal broaching operation. The next one is external broaching. External broaching takes place when the broaching tool machines an outside surface of a workpiece. For examples are the machining of flat surfaces, cam surface, and gear or ratchet teeth. There's a video of external broaching. Now that's the result of the external broaching. The last one is pot broaching. Pot broaching operation uses a ring or tubular shaped broaching tool with the cutting teeth on the inside. Normally, the workpiece is pushed through the tool with hydraulic force. The tool cuts the entire workpiece periphery in one pass. Machining of gear teeth is typical application. And thank you, that's all for today.